In the last few videos, I showed you amines, and in particular was ethylamine, involved in SN2 reactions. But what I want to show you in this video, it doesn't always have to be an SN2 reaction. In fact, in this video, we'll look at an SN1 reaction. So say I had some methylamine. So let's say it looks like this. So this is our methyl group bonded to a nitrogen, which is bonded to two hydrogens, just like that, and has its lone pair. So this is methylamine. This is methylamine right there. And let's say it's in solution. Let's say it's in solution with something that looks like this. Let's say we have something that looks like this. So then we have a bromo group. Now, there's a couple of different ways that you can name this, but maybe the simplest way, you find the longest chain here. It has 1, 2, 3 carbons, so that is a propane. So this is a propane. This is a propane, and then on the 2 carbon, regardless of whether you start counting from here or there, so this is 1, 2, 3. On the 2 carbon, you have a bromo group and you have a methyl group right there. So this would be 2 bromo. You want to write in alphabetical order. 2 bromo, 2 methyl, 2 methyl propane. What we care about is what would happen over here. Now, over here, you have a situation where you have a carbon right here attached to the bromine. And if your brain is really in SN2 mode, you might say, hey, maybe these electrons attack this carbon, and then this electron that's with the carbon right now gets taken by the bromine. But if you really think about what the conditions for an SN2, you'll probably remember that this won't happen because it's sterically hindered. You have these 3 other carbons here. You have these 3 other carbons here. And actually, these are not just carbons. These are CH3s. The hydrogens aren't even drawn. But this is a CH3 here. This is a CH3 over here. This is a CH3. These things are going to block the nucleophile's access to this carbon. So you're not going to see an SN2 reaction here. But what you can see is because this guy is a tertiary carbon, he is bonded to 3 other carbons, it would actually be a fairly stable carbocation. So what you could see in step 1 of this reaction is just the bromine leaves. So if you have just the bromine leaves, then our situation looks like this. You have a tertiary carbocation. This electron leaves, so it now has a positive charge right over there. That's why it's a carbocation now. And now the bromine has taken an electron. The bromine, it already had 1, 2, 3, 4, 5, 6, 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. And it just took one more electron from that carbon. So it just took one more electron from that carbon. It now has a negative charge. It's now a bromide anion. But now this now that the bromine is left, now the methylamine can get involved. And this should be methylamine right over here. So now this has, we learned in the previous video, has a partial negative charge, has these extra electrons. It will be attracted to this carbocation. So let me draw the methylamine. So you have the nitrogen, hydrogen, hydrogen, bonded to a methyl group right like that. And in an SN1 reaction, that's what this is. Remember, the rate determining step right here only involves one of the reactants. That's where the number 1 comes from. In an SN1 reaction like this, the nucleophile can attack from either side. This no longer is a tetrahedral shape. It's now a triangular planar shape. So it could go in from this direction or from that direction. So in this case, well, I'm just going to draw it in this direction. So this nucleophile, this nucleophile can give this electron right here to the carbocation. In which case, we will end up with something that looks like this. We have our nitrogen. It has bonded to 2 hydrogens over there. It has a methyl group just like that. It has this electron over here. Now this magenta electron has been given to this carbon over there. And then that carbon is bonded to 3 other carbons. 1, 2, 3. And so just like that, we have created, oh, and we have to remember, we've given away an electron to this carbocation. The carbocation is now neutral. It gained an electron. Let me write the carbon right there. Gained an electron. It's now neutral. But since the nitrogen gave away an electron, it now has a, it now has a positive, charge. So what will we call this molecule right over here? And now this is a little bit tricky. So you have a methyl group over here. It's definitely, well, this is no longer an amine, it's an ammonium because it has this positive charge. We have 4 bonds on the nitrogen. So we could call this right here, we could call this N-methyl. That tells us that the methyl is bonded to the nitrogen. It's not bonded to the other carbon chain. N-methyl. And then this right here, these 4 carbons, 1, 2, 3, 4. This you could view as a tert-butyl group. There's other ways to name it, but that's the most common one. So it's N-methyl, tert-butyl, tert-butyl, ammonium. Remember, we have that positive charge there. Ammonium. And then we saw in the previous video, this is an ammonium right now, but you had some of your original methylamine floating around. So you had some of your original methylamine floating around. If you have some of your original methylamine floating around, and this could in theory, or it can in practice even, nab away one of these hydrogens, or at least the proton part. So it gives its electron to that hydrogen, and then the hydrogen's electron gets taken back by what was an ammonium. And then if you have that, and this is a reversible reaction, it could go in either direction. This methylamine is now methylammonium. So it now looks like this. It now has 3 hydrogens on it, right? Because this guy bonded with that hydrogen. It now has 3 hydrogens. So this is methylammonium. And then this thing over here will now look like this. Lost a hydrogen. So you have a methyl group bonded to an N, bonded to an H, which is then bonded to a tert-butyl group, just like that. So now this has become, as I just said, this is methylammonium, but this over here is N-methyl. Once again, the N tells us that we are bonded, that this methyl group is bonded to the nitrogen. N-methyl tert. And now instead of calling it butyl ammonium, and actually we didn't have to have this dash over here, this was butyl ammonium, it's now butylamine. Tert-butyl. And then obviously, because we have that nitrogen there, butylamine. Anyway, I just wanted to show you that the mechanisms or the reactions I showed in the last video, they're not the only type of things that can occur. You can also have Sn1, and in general, it can act as a kind of a, well, I'd say it's a weak base. It's definitely not a strong base, but it's the most basic of all of the neutral functional groups, which I said over and over again. So there's many different types of reactions. I've just tried to give you a sample of a few.